time for interlocks. So I just got this functionality finished and working. I've got these two valves and turn them on and off as normal. These two valves, if I turn them on, they will inhibit selectively the other valves. And I can have that valve turned on, turn on the valve that triggers the interlock, it turns off. If I have both of them on, just the one that's inhibited turned off. If I have them both turned on, the one that inhibits both of them closes both of those valves. While they're inhibited, notice that it's staying the bright green. That's the signal that it's not accepting the command. Right now I don't have good feedback that the command was received but ignored. So that's, you can set up, I set up some process values indicating whether or not the valve is inhibited to give some sense of feedback, and I'll at some point maybe come up with a way of better representing that it's inhibited. One of the things I'll probably do is in the configuration for the front panel element, add a new inhibit channel configuration. And anytime that value is true, it would disable and gray out the control, so you couldn't even attempt to try and send a command. That's probably what I'll do to implement that. So this is pretty simple. So this is just a very generic, nothing named specially. I'm still using the simulated CDAC chassis in Max and DAC-MX for most of this simulated I/O functionality. So just have a bunch of digital output named channels. And then in the digital control, which has been what has supplied the bang bang, the discrete control for ullage, heater PWM, valve timing, all sorts of different digital control capabilities. That is now where this interlock behavior lives. So it's as with most of them, the control element itself is the command channel. So you can attempt to turn DO04 int on or off. And if it is not inhibited, it will just forward that command to the proper output, which would be presumably a valve channel or some other control in a test system. However, we can also configure conditions that, if met, inhibit this control. And so for this, if DO10 becomes true, we're going to put this control into an inhibit state. We'll track that with this channel. This is how we get those red LEDs on the front panel. And when we're in an inhibited state, we're going to force this output value to false, which for a valve would be closed typically. Similar thing for the DO08, except it's got two conditions, and you can do any or all. So still single tier conditionals, nothing super complex here. Anything more complex than this probably would just write a module so I could implement arbitrary conditionals in code. But this will cover most use cases, most any of the basic use cases. But this one, if either DO9 or DO10 become true, that will put DO8 into an inhibited state. So pretty simple to configure. And of course, this all adheres to the control loop period. The made of notice, these 9 and 10s go to the, almost seem to go directly to their dull colors. Every once in a while you might see the brighter flash of the transition state, whereas these will almost always show you their transition state for longer because it's got to wait for that next 10 millisecond interval to respond to the command, check the interlock and all of that. So little bit of latency to add that check in this mechanism, but for most things probably would be running at 10 millisecond period, and 100 hertz control is not that slow. But yeah, so yet again, more functionality available in Volatus.